Good morning, everyone. Welcome to our online web session today on product release, end of life, and security compliance monitoring. My name is Alex Aschauer, and I work in business development at Virgia.io. For today's web session, I was able to win our CTO, Matthias Scholze. Today, we would like to give you a conceptual insight and report on our practical experience in the area of product lifecycle. Furthermore, we will show a live demo how you can efficiently implement compliance monitoring of product versions with Virgia.io. Please post your questions in the chat. We will answer them at the end of the web session. And now the stage is set for Matthias.
Thanks a lot, Alex, for the introduction and a warm welcome from my side as well. When we talk about product in the life cycle, the first step is to clarify what is a product. In our world of products can be an operating system, a software product, a software framework, a device, or even a content pack. So what is a product version number? The version number defines a specific version of a product. It must be unique and identifies the state of each artifact belonging to the product. Artifacts of a product are, for example, software code, configurations, documentation, content, etc. What does a version number look like? The version number is determined by each product vendor. The classic format is major, minor, and patch. Major indicates a major version and signals an extensive functional or technical leap. A minor version is usually used to deliver smaller functional enhancements. Patches are usually used to fix functionality or security issues. But as I said, the product vendors are free here and use that. So often commit, build, service packs, etc. are also integrated as version component. And this makes the whole things a challenge in practice. There are no uniform standards to the format and the version components. And notice the version number is a glue between all things that we do in product lifecycle management. I have listed here as an example two version numbers of Java version and a switch. Often we also find inconsistencies in the version numbers. So there are often two different versions at the same time on the same unique commit in the version management. Let's make it hard to decide which one is the newest one. Many vendors publish their version history on their website in a non-machine processable form. This, of course, makes it difficult to build up an appropriate knowledge base. We should talk again about what is the motivation to actively manage the life cycle of the deployed products. Current versions are subject to natural hardening of the product. So we can expect fewer security vulnerabilities, fewer functional and non-functional bugs. This is how we reduce risk. If very old versions are used and then a security problem comes down for them, then you usually get really into time stress. On the one hand, you have to solve the security problem promptly. On the other hand, the update over several versions cannot be done easily. The more current the used version are, the easier the necessary update or upgrade will be. Especially with the paid products, it is usually more advantage in the sense of investment to be able to use all the functions and optimizations of the new versions. The planability should be mentioned. The use and update of specific product versions is always a part of coordination with, for example, software development, enterprise architecture, and IT security team. And currently, Red Hat reduce automatable work in times of a shortage of skilled employees. What are the specific characteristics on which we can evaluate a product version? First of all, it is the version number itself. It tells us whether it is a stable version and whether it is one or the latest version of the latest release. Secondly, there is information about each release, for how long maintenance and support is provided, and whether long-term support is offered for the version. As a third piece of information, we can add known security vulnerabilities for the product version for evaluation. Which characteristics of a product version is evaluated in the context of product lifecycle management, and how must be data mined on a customer-specific basis for each IT system, application, technology, etc. Okay, in life, not everything is always optional. Organizations and companies that are classified as critical for the maintenance of society are subject to regulatory requirements. In Germany, we have the BaFin, Bundesanstalt für Finanzdienstleistungen. The BaFin is a regulatory organization for the financial sector. In its document Regulatory Requirements for IT, called BITE, the BaFin clearly defines that IT systems, products, versions must be kept up to date, and that products must be managed without maintenance and support. There are similar requirements for all companies and other sectors that are classified as critical infrastructure. What are the right ingredients to monitor and verify product version compliance? First, you need a mechanism to capture the product versions in use. The best way to do this with an agent that inventories and documents product characteristics. Version.io provides a one importer. It's a kind of agent that you can install on a host with capture all technology versions 100% automatically. Third-party systems that have information about deployed product versions can be considered as a supplement. This includes monitoring solutions, cloud container, virtualization platforms, network devices, etc. The data quality of the versions information in terms of completeness and correctness must be taken into account here. Especially with third-party systems, there are often problems here in our experience, as they do not have version detection in their product focus. Next, we need information about all versions of a product to be able to match them with the characteristic of the detected versions. In most companies, we see that these are manually collected from the manufacturer's websites and managed in Excel. In Version.io, we offer a daily updated product version content database for you. The last ingredient is information about known security vulnerabilities, also abbreviated CVE. This documents the security vulnerability, provide scoring for better prioritization, and the affected product version numbers. Again, we provide all daily updated CVE database. Currently, we are importing CVEs from the National Vulnerability Database, a US-based federal agency, and the vendor Red Hat. In the next step, we will import CVEs from GitHub and provide them to you. With this, we have everything together that we need. So I hope I was able to show you again the basics about product lifecycle management. Now I would like to show you in the live demo how you can implement the compliance monitoring of product releases, end of life, and known security issues in Version.io. Now we are in Version.io. I have set up an environment with specific data for you. And the first thing I want to show you are the 3 ingredients that we need for the product lifecycle compliance monitoring. At first, I install the one importer on 2 hosts, and this one importer, it's a kind of agent, are able to inventory the host. Yeah? He can detect the host, the processes that's running on the host, the service that the process delivers, and the related application. Let's see in the topology analysis, there I have topology defined, and you can see all 100% automated detected values from our one importer. And you get not only the instances of all things that the one importer detected, also the relation. So we are able to build up here a topology in this kind that you can show, can see here in Virtual.io. We see here an application. This application uses services. These are the yellow bubbles here. The yellow bubbles are services they will provide by processes, and processes run, in our case, in a Docker container, and the Docker container run on a host. And now we go in the host and we can see the specific configuration of the host. This is the actual state of the host, and we can see here version information. And this is our business clue to combine it then later with the product lifecycle database or the vulnerability database. And another example, if I go to the processes, looking for a Docker container, and here we have, for example, a Tomcat process, then I get in the technology section the versions of the Apache 2. Apache needs for execution a Java virtual machine. That's why we have 2 technologies that are necessary to execute an Apache instance, and we see every time that we detect the complete and correct versions of the products. That is the first and most important ingredients that I can show you here. The second one are databases, our content databases, and we provide the product lifecycle and the vulnerability database. Let's start with the product lifecycle database. Here we have a lot of technologies that enterprise customers use. And here you get detailed information about the product in generally. And here you can see details of a release, the last patch of the release. You see characteristics like long-term support. You see the maintenance and the maintenance period time, and something like that. And that you have here available for all these products that we support. And we can use this information later to detect if we have good information or not. And in the same way, we have the vulnerability database. Here you can see NVD, Red Hat, and later GitHub CVEs that we import daily. And here you have very strong filter capabilities, for example, to filter for attack vendor network. That means that is possible to attack the technology via network. It's not necessary to log in the technology section itself. And for example, we can look for a specific product, in my case, Tomcat, and we see here that we have in our database 207 CVEs available for Tomcat with an attack vector on the network level. Yeah. Okay, so we see 2 databases, 2 ingredients. We have the detection. The third one we have all together. And here in our product security and lifecycle section, you can see our live compliance and state dashboard. You see some statistics about used technology that you are running at the moment. Versions, products, vendors, tags. You see here security statistics, life cycle compliance statistic. You see here the technologies or the products that you are use, and in the bottom you see all details about the products and the version that you use in this product. And the most important thing is our recommendation about the compliance and life cycle state. You see here red and green flags. And let's jump in for one product and see why this flag are red and green. Here we have a red flag for security. That means we found for this version of, in this case, a network device, it's an operating system of a network device, we found a lot of CVEs with security issues that based on this version. That's why security flag is red. And for the product life cycle, we have recommendation from Version.io itself, and we say to you for this product, this is our recommendation, what is necessary to operate this network device. In this case, the network device is not operating on the latest release version, and that's why we can recommend you to update your network device. The next version is the 22R3S4, and other versions are also possible. All versions are higher than the original version, and all these versions are compliant on the lifecycle and on the security side. And that we have the same here, for example, on the Ubuntu side, you see there are no CVEs existing for this version, but we have a lifecycle problem because also we are not running in the latest version. You can see it here that there is a newer version. So you can update this instance. Here you can see the instance to this version, and then you are compliant again. If you like, then can you create here directly a change request ticket, and you can see here the predefined involved instances and the expected attribute change. That means we have here the possibility in Version.io to monitor and to document the change request execution automatically. Okay, we come back to our dashboard. Dashboard means that is predefined, zero configuration, and the dashboard works with a recommendation from Version.io. Yeah. So if you like to specify your product lifecycle strategy for your corporate, then you have the possibility to generate own rule set. It's very easy. You can use our content database for it. You select the technologies that you want to verify in your environment. I take all technologies, and you can generate a rule set, and here you can define your own product lifecycle strategy. That means you can say, okay, I will use this latest patch. You will use only latest releases with long-term support and something like that. Yeah, and then you generate it, and it's so much easier if you have the possibility to generate it. On the other way, you have to define the rule by hand, and no one of our customers like it to do it. So it's easier to do it automatically. Okay, I prepared one rule set for you, so we can looking for the results of it right now. And we see here the violation detected by Vergio.io, and we see here, for example, the network device or the host and a lot of processes. Again, it's a little bit the same like in our dashboard. What is the different here? It's your strategy. Yeah, it can be another strategy like that we use in our standard dashboard. And here you are audit-proof. Audit-proof means we capture the creation of the violation and the end time. At the moment, this has no end because it's still active right now. And you can see here the rule, how we verify the state of the version of this Juniper network operating system. And you can see here again, we have an old version in use and there are a newer version available. Okay, that means you have two possibilities. Use our zero configuration dashboard with a recommendation from Vergio.io out of the box, or define your own governance, compliance, and risk rule sets for you. Here is the advantage that you have audit-proof data. For example, if an auditor comes in your company and see this documentation, it would be very happy. Okay, that should be all for today from my side, and the stage is back to Alex.
Thank you very much, Matthias. Let's summarize the important points again. For the implementation of a product lifecycle compliance monitoring, you need three main things. First, a product version detection, then a product version database, and thirdly, a security vulnerabilities database, CVE. We at Vergio.io believe that you can only successfully solve the dynamic and mass data in the area of product releases with automation. And if you have successfully established product lifecycle management, then you can very well proceed to other things like change request monitoring and documentation, integration into the product update process, or include the lifecycle results to corporate risk management. Before we get right to the Q&A session, a quick note about our next web session on the 2nd of June. The topic will be full stack IT inventory and change detection. Thank you very much for your interest again, and now questions from your side.